For people that are new to the group, I just want to take a quick moment and explain the original premise of these Hangouts. We're not here so much to learn about how to use these libraries and frameworks and tools as we are to see how they work on the inside and hopefully derive some kind of nerd enlightenment from the experience. That said, it's sometimes easier to understand how to use a package effectively by looking at its implementation rather than just reading the docs or playing with toy examples. Documentation can mislead and sometimes even lie, but code always tells the truth. So when you're starting out on a project, you can afford to treat external dependencies as black box abstractions. But once you start hitting those tricky edge cases, you're just begging for trouble if you treat your foundational components as being completely opaque. Reading the source can be an intimidating thing to do at first, but it's also a really important skill for an advancing developer to acquire. So aside from learning the tools or learning the internals of any given tool, if we have a big picture goal for these Hangouts, it should probably be to lower the psychological barriers to this kind of exploration. That's where we're coming from, and we hope that everyone walks away with something valuable. So let me introduce Nick Niemeir. Nick is a badass hacker, if I ever knew one. He works on browser instrumentation at New Relic, and the word on the street is that he's doing impressive things with React. So Nick kindly agreed to help take us on a first look under the hood. So let's turn it over to Nick. Thanks for coming.
Hey, thanks. That's a wonderful introduction. So I want to be clear from the start here that I'm kind of a tourist in React's code base here. This is stuff that I haven't written, and I've only gotten interested in how it works through using it. So as we're going through here, all comments are my own and not from the position of someone who's written any of this. I also want to be clear that I'm using this stuff for production code. It's all really, really great. It works extremely well, so anything I say that's negative is definitely nitpicky and not a condemnation, because this is stuff that I'm happily using in production. So I'm going to share the link to the notes that I've got here to start with. Feel free to snag some links out of there as we go through. I'll be browsing through on my own editor, but those are links to GitHub, so you can follow along. Yeah, so what is React? React is a really robust functional view layer. It's pretty amazing. It doesn't handle a lot of the other stuff that you need, the syncing with the server or modeling your data, or even the controller style stuff. It's just focused on that view layer. Except, unfortunately, it's a very big library too. It's really complex, handles pretty much all the edge cases that you need. But it's not a small thing to learn. I guess the API service area isn't too big, but it's not a small thing to read through. So we're going to be focusing on a very small portion of it. So when you're using it, it puts the view code and the templating code combined. So it's kind of a weird thing to get used to. There's no external Jade template or something where you're describing your DOM external to the things that bind into it. It's all described in JavaScript, and you create a virtual DOM out of function calls, or you can use JSX, which is their basically templating thing over it, but really that just gets compiled down to JavaScript function calls. So we're going to be kind of ignoring that XML-like syntax in JavaScript. That's a whole another thing that some people like and others don't. So we're going to go straight into how you create a virtual DOM tree using function calls and how that works in. All right. So, got a quick example here of basically how you would use this stuff. So this is without any context, pulled out of basically how one of these would get instantiated before it gets mounted into the DOM, before it gets used as part of a component. We require in React using CommonJS, so this is getting built with Browserify or something like that, some other CommonJS module system. And we reference React.dom as D. This is just something I do to make it easier to type these functions. It gets really verbose if every time you're creating an element you say React.dom.div. So I just alias that to D for brevity's sake. So we're declaring a virtual DOM element here. And we're giving it the root node is a div with a class name of container. And we're having a div inside of that with a class name of contents. And then that has three children, a start, a middle, and an end. The start is a paragraph, middle is an anchor tag, and the end is another paragraph. We're just logging that all out to show what that looks like. So if I hit F2 in my editor here, it lets me print this out, and we can look through what's there. And so these are all the first level properties of these. This doesn't have all the methods or anything else, any of the things. A lot of the objects in React have fairly deep hierarchies. You'll have things with prototypes and multiple constructors and stuff. So you don't get to see all at the top level here with the JSON stringify. But it shows you kind of what it looks like. The middle A tag, for example, you can see the key middle is preserved. This doesn't have an owner because it wasn't part of a component. Has some context and store stuff that's inside of it, and the props that are related to it. So we're going to start with where do these functions come from, the d.div and the d.p and the d.a. So those all get built out of a file called react.dom.js. The first thing you'll notice is that all of the requires are absolute requires. They're not relatives. They made the decision that they wouldn't have path names in their require statements, which is kind of a pain because it means you don't know where to look for a file just by looking at the require statement. But it has the advantage is that means they can move files around within their directory structure without having to go change things in a whole bunch of different places. So it's a bit of a trade-off of easy to move versus easy to read. But they do a good job of keeping the file names consistent, so it's still not too bad to find things. So if we look here, we can see all of the tags are defined using the tag name and either false or true as an object. And so they're going to use this list of tag names to create each function for each object. So the true and false, let's see, I don't remember what that does, but if we look at how they map over the object here, they're mapping it over with a create DOM component class, which is here. So that's getting the tag name and then whether or not to emit the closing tag for self-closing tags or anything that doesn't close. So it's a really easy way to define all of the different tags that you need. One thing that they have here is SVG. Anyone who's used SVG can tell at a glance that this is not nearly full SVG support. That's unfortunate. There is a branch out there that has a whole bunch of stuff added to this, but I think they mostly didn't want to do this for the sake of size. But it's a little sad having kind of partial SVG support. But I've been using this for SVG stuff, and I really haven't run up against it very often. So it's really not that bad. But if you're using SVG, you can expand React to have all the SVG elements.
Hey, Nick, can I ask a quick question on that?
Of course.
For the SVG, is it easy to extend that?
So it's all kind of baked together. So it'd be easy to build a custom version of React that had this, but it wouldn't be so easy to extend it externally. But if you wanted to vendor this as a dependency, it would be super easy to add any tags you wanted to this.
All right, thank you.
Mm-hmm. All right, so this is the function that gets mapped over each of those. So think about this walking through with a div tag, and no, we don't need it to close off the div tag. So we create a constructor function for each different one. We use React DOM component to create the prototype for that, and then reinitialize the constructor property over what this overwrote. And then we say the display name is the original tag. So let's go ahead and dig into React DOM component here, which is going to be the prototype of our constructor function. So this is a React DOM component.js and source browser UI. This is the start of the prototype here, the thing that creates the prototype. Really super simple. Just adds a couple of private things and says the tag is uppercased. It's nice to have this always cased the same. And then what we want is the prototype stuff off of that. So this object gets created, and then I think that's it that happens right now, because we don't have a prototype here. Yeah. Okay, so that just means that our objects will now have a prototype with stuff like this. Go down, we've got some dev stuff. I'm just going to skip over everything with an if dev tag on it, just because it's not very relevant to what we're working on. This React legacy descriptor. So this is supporting some legacy stuff that puts some deprecated warnings around old methods. And this stuff is going to be going away, so we're going to skip over that as well. Where are we going after that? We've got mix-ins. Okay. So, okay, so we're going back a step here. So inside of React DOM component.js, there's a whole bunch of stuff that you can't see in this file that's relevant. So basically what happens is this object gets created, this constructor function gets created here, and then the prototype stuff for this all happens down down here. We mix stuff in from the component, from this component itself, from the multi-child component and the browser component mix-in. So we're going to look at React component.mixin here. Yeah. So everything inside of this mixin object gets added to the prototype for the DOM component. It's got a whole bunch of utility methods included, things like isMounted. Lets us tell if we've mounted this component yet or not. If you look at the original one here, you can see that we're not mounted. I think it's false. This doesn't bubble up to here. it's got a couple of lifecycle stages, whether it's been mounted or not. You can only mount an instance of a component in a single place. So if it's been mounted before, you can't do it again. Allows us to set properties on the component. This is pretty cool. It lets us change what goes into to building it, and it merges the ones that we set with the ones that are already existing. We've got a function to replace the existing properties. This just lets us pave over them. You'll see this invariant function called all over the place in the React source code. Basically, this is just an assertion, making sure that the first argument is true, and if not, it throws an error on the second one. They minify all this stuff out when it gets minified, though, so you don't get good error messages unless you're running the development version. It's kind of a pain, but on the other hand, it saves space, so it's a fair trade-off. All right, clone and replace props. Yeah, update. Queue update. Yeah, so this is basically just getting things ready to re-render after the properties have been updated. Set props internal. I'm going to skip over some of this internal stuff that you should actually be using. Basically, they've tried to separate out de-optimized paths from optimized paths and isolate the de-optimized stuff that doesn't get used very often. It's nice because it's great for performance. It's kind of bad for the size and complexity of the library, but it means that we don't de-op hot code paths, which gives a huge upside. So construct is this is the main constructor function. This gets called anywhere that we create one of these virtual DOM components. Exposes the properties off of itself and the owner from the descriptor. Adds the lifecycle state from the lifecycle thing, starting with unmounted. We set our pending callbacks to null to start with. This is for updates in the future. Set our underscore descriptor to the descriptor in the pending updates. So at this point, you'll notice that it's kind of Java-like in some ways. That we've got now like 3 layers of objects and object constructors, most of which are just adding a few properties to the object and maybe changing the prototype. So it turns out that JavaScript is actually the fastest when you write it in this style, when you've got very sort of rigid object hierarchies and you're setting properties that you don't know if you'll use to null to have them there, but so that you're not adding properties to objects on the fly when you can avoid it. This stuff, I find it harder to follow, but it makes it blazing fast to execute. Another thing we've got is a mount component. This is a function that we use internally so we can mount the components. This one just again sets some more properties. Make sure it's not mounted before it starts, and adds the component refs to the owner. So mount has a corresponding unmount. This lets you cleanly collect anything that's already been mounted. Pretty straightforward. Receiving components. This is another function that gets mixed in. Perform. Oh, okay. So this does a check of the new transaction and updates it if it needs to. Perform update if necessary. This is checking to see if our component's been updated since the last time that it's been rendered. Our previous descriptor or next descriptor becomes our pending descriptor. We check to see if well, first we check to see if our pending descriptor is null. If it's null, that means we don't need an update. If it's got a value, we go through and up ourselves from one descriptor to the next and update the component. Update component.
Nick, there was a function in there. I think it was called invariant.
Yeah.
In a couple of those, do you know what that does?
Yeah, let's go into that. So that's
You said it was an assertion. I think it's.
Yeah, it sorts utils.
Vendor code.
Oh,
Vendor core. Vendor core invariant.js.
Thanks. Yeah, so this one is it's really weird because really all it does is throw a new error with the message from the second argument. Except that if it doesn't have a format because it was stripped out for minification, then it just throws an error not showing what the actual error message was here. It's really unhelpful, but yeah, it's basically they're trying to add static checking so that they can make sure their code is correct before it ever gets executed. Really, I don't know, kind of an interesting thing, but it kind of loses the beauty of the dynamicness of JavaScript to go through and assert all of your arguments all over the place. But I can see why they do it. When you've got a large team, it definitely keeps people from stepping on each other's toes.
Thanks, that was really helpful. Yeah, I had a question. Thank you, Nick, about that. But as far as like you said that it makes it really fast when you use that style of all of the Java-like objects.
Mm-hmm.
Or you have that? Did I say that correctly?
That's the gist of it.
So I mean, how does it keep track of all this stuff? Where if it's so fast, I mean, is it doing like checking on these objects, or is it mapping them somehow? Like how is it so fast?
So basically, Hotspot and V8. Hotspot's the JVM's underlying engine, and V8 were basically written by the same folks and using a lot of the same techniques. So we have to keep in mind that really the people who are writing our fast JavaScript engines are really C++ developers. And you can definitely see some of that bias in what things get optimized and what things don't. Basically, V8 is super, super fast at dealing with objects whose properties are always declared and never added to or removed from. They're basically static types, if you think of it from a Java perspective. Which is kind of annoying because if you run a bunch of code and you're passing in objects and they always have the same things, it can optimize that as the hot path. But as soon as you pass one in that's missing a property, it has to de-optimize that to deal with the new type of object. Or if you've added another property on the fly, it has to de-optimize it because they're not the same. They're not the same underlying class. It's basically got this whole static class system underneath it for optimizations purposes. Yeah, it's kind of annoying and counterintuitive. But there are a lot of talks out there, including partner of mine, Chase, gave a good talk about that at FluentConf this year. So I think his is out there. And then David Manning gave a good talk about it at Cascadia.js. And they go into much more detail than I can on how that works.
Cool, thank you.
Yeah. All right, so let's go ahead and move on to the next mixed-in part here. So this is the multi-child mix-in. So again, all of these functions from mix-in get added to the constructor for the React component. This stuff is all pretty gnarly. But basically, it's letting you have many children to a single DOM node, which is definitely important, and lets you nest children inside of each other. So the first thing that happens when you try and mount all of your children is you flatten children. That's maybe not a good method name there, but inside of flattened children, the main thing it does is traverse all children. So we're going to go take a look at the traverse all children file here, and all flattened children does is add one to make an array out of these traverse children. So the start is if children is null, you just return 0. And otherwise, you run the traverse children implementation. Again, this is a performance optimization. If you passed a null instead of an integer into traverse all children, it would de-optimize the children as an integer path. So they just take care of it with a method outside of it that can be. They don't care if this method gets de-optimized as long as the traverse all children implementation method never does. So we take a look at a traverse all children implementation here. It's a function that takes the children, the name so far, the index so far, a callback, and the traverse content, and keeps track of a subtree count. And make sure that children is an array, and iterates over that array using a for loop. Again, for instead of map or for each, because for loops are more optimized in V8 than a dot for each or a dot map for silly reasons. But really, it's because they're more used, so there was more pressure to optimize them well. So the child is the current member of the children array. The next name is going to be the name so far, and then as long as there's a name so far, we put the separator in the middle of it, so we don't have a separator at the start, and then the get component key, so the key of the next child. So what that does is it lets us build a unique identifier that combines the parents' names as well as our names separated by the separator. Let's see what that is actually. I think it should be. Oh no, it's so the sub separator is a colon. There's another separator that's somewhere else that I don't know how to get to it. So basically, this is building these things separated by colons of ID. So basically, any ID, each level has its own unique key, so you can identify who you are and who your parents were and who your children were based on these IDs. Next index is index so far plus subtree count. So that's our depth plus the index so far. Then we add traverse all children implementation. So we add the result of recursively calling ourselves to the subtree count. So this would be how we walk through this as we go. With the next name, the next index. And and if children is not an array, we see what the type of the children is, and see if it's an only child. Set the name so far to empty string. If it's the only child, treat the name as if it was wrapped in an array, so there's a consistency. If the number of children grows. So basically, let's treat a single child as a single element of an array. Checking the storage name, whether it's an only child or not. If children is null, so note the use of double equals here. Double equals on against null means null or undefined. It's one of the few good reasons to use a double equals, but it's still kind of confusing. It'd probably be better to write that out explicitly as a triple equals null or triple equals undefined. Or if the type's Boolean, so if it's null undefined or true or false, we come in here and call the callback with the traverse context, null the storage name and the index so far, and set the subtree count to 1. Otherwise, we check to see if it's a valid descriptor and call the callback. So basically what this is each leaf node of this tree or array structure we need to call the callback for. We're setting the subtree count to 1 for each of those. And if it's an object, so it checked for an array first, so this won't get caught for arrays. But if it's a non-array object, we check to make sure that the children exist, or the an invariant of not children. So if children is false or node.type does not equal 1, we fail our invariant. And encountered an invalid child. Okay, so this is trying to catch if you send a DOM element in as a child of a React component. So putting a real DOM node in a virtual DOM tree, which would cause all kinds of problems. If we pass that invariant and we iterate over the object of children virtual DOM nodes, to make sure that we're only iterating over has own properties, so we're not traversing that any further. Adding to the subtree count by recursively calling traverse all children again with the each child and its key, adding the name to the name so far, incrementing the index so far with the subtree count, passing the callback down, because this is not a leaf node, so we don't call the callback. We just pass it in and then traverse the context.
Man, that's a huge conditional.
Yeah, we're not done yet.
Like, and is this I've seen this in a lot of node modules too. Is this really more performant this way?
So this has a mix of things that are done for performance optimization and things that really hinder performance optimization. So actually, the size of this method really hinders performance optimization. It's right around the limit of where V8 will just sort of throw up its hands and say, "Screw it, we probably can't optimize this." It's probably under the limit, but it's close. And having these this different stuff where you can switch based on type is not a good thing for performance. So basically, the best way to optimize this would be to split everything for each type out into a sub method. It'd be, handle object child, handle string child, handle number child, and that would create, I think, a cleaner code as well as easier to performance optimize.
Wow.
Yeah. Yeah. Okay. So if we get a string child, we normalize the text and create a text component of it. So this is so we can have contents and stuff without having to wrap them in anything. Then that's a leaf node, so we call back. And if it's a number, we coerce it into a string using a concatenating it to an empty string. And then do the exact same thing as we did before for strings. And then out of this function, no matter what else we did, we return the subtree count. So yeah, basically that every time it comes back and we call it, we get how deep we are into this subtree. So this is a monster of a method, but it does some really amazing stuff. I mean, this is the sort of thing that's going to get a lot faster in ES6 as soon as we have optimized tail recursion. A lot of times, a lot of these branches, the last thing we do is call ourselves. So I think that could get a lot faster without any additional work by the React folks.
What does that look like? Is that 'cause I don't know that particular spec.
So basically, it's adding optimized tail recursion like you get out of Scheme, so that every time you call a function, if the last thing it does is return another call to itself, instead of adding to the stack, it will replace the last stack frame. So basically, you can create iterative processes out of recursive function calls, which is impossible in JavaScript right now. In theory, if you've got a big enough DOM tree here, a big enough subtree, you could run out of stack frames. I don't know what the normal limits are, but it's big enough you wouldn't want a DOM tree that size anyway. So it should never be a problem, because if you tried to add that many nodes to a DOM, it would fall over. That's a
And so far, we're just building up a giant string or a collection of elements, right?
Yeah, so it's this is letting us look at every single child in an entire virtual DOM tree. It lets us see all of the leaves in that structure. So if we had a big chart that we were adding, then we would be able to look at every element that got rendered using this method, or that was going to get rendered. This is also probably going to get called when they do their diffing algorithm to compare one to the next. They can see what's happened. All right, so I think that's all of traversing all the children here. So let's go back to where that was getting called. So basically, flatten children is using traverse all children to build an array of those children, so you can get at each one. Not sure what mount images or index are going to get used for here. This underscore rendered children, just assigning all of our flattened children to it, and then we're going to look through the children by name. So this is using those unique identifiers. And the child is the children name. This doesn't guard against own property here. I wonder. Oh, yeah, it does right here. Okay, so the rendered children must be turned into instances they're remounted. I'm actually not sure what that means. I guess as we mount things, though, we're instantiating the React component and calling that a child instance, and then assigning children name to the child instance. So we're reassigning this over ourselves after we've been instantiated. And then inline for performance, React handles create ID. Okay, so this is creating a new ID, not making a function call for performance reasons. It's a little weird. It should be able to inline itself through hotspot optimizations. Then we're mounting the component. So each instantiated component then gets mounted with the root ID of this element's root ID plus its own name, and then added with the transaction into the mount depth that gets incremented. Oh, I guess the mount depth doesn't get incremented. It's one deeper than the mount depth of the parent. That makes sense. And the child instance gets the mount index of index, which we defined up here as 0, and then increment down below. So this is how it gets its unique index, just incrementing from 0 for its level of depth. And then mount images.push mount image.
So how many different places is this information stored? Is it like it seems like we have a couple of different objects, collections, or arrays or something that we're mapping back and forth to. Is that right, or am I misinterpreting that?
So I'm not entirely sure. So there's one master tree, essentially, of the DOM nodes for any component. But I think each of them has some information that's kind of getting transformed back and forth. Basically, as we're doing that iteration of the children, we're getting these names out, which we're then reassigning to the main tree. So I think it's short-lived information versus long-lived information, if I'm reading this right.
Okay.
Okay, then mount image is the post mount child instance, and we're pushing that into the array of mounted images. And then once we're all done, we return all of the mounted images that have been mounted by mounting the children. All right. I think this is a good point to take a quick breather here. Is there any questions from anyone?
No, it's a lot of control on that, and trying to figure all this out. So I'm imagining there's a lot of edge cases and things that React has thought about and fixed in that case.
Yeah, that's one of the big advantages to React is that it is very, very battle tested. Whatever else you can say about it, it's probably getting more page views from Instagram than any of us will ever be generating.
Right. Now, as far as this is, like I said, just building up this tree, and is there these subtrees that are more optimized so you don't have to traverse the entire object set?
So I think you can start at any point. So you can start at any component, but if you start from the top, you get the whole thing. I don't. If you're re-rendering, though, it's smart enough to bail if it finds a difference. It won't iterate through all the children of a component that it knows has already changed.
Mm.
It assumes that it has to rebuild those whole things.
That's quite a lot to chew on, Nick.
Yeah.
Yeah, I'm still trying to wrap my head around it. It's
That's
pretty
great.
cool stuff, though.
Great.
Yeah, it's pretty amazing how this stuff works. And really, it brings us back to kind of an era of web development that's you can kind of think of like the early CGI script days where you're generating your pages programmatically, but you're never updating them. You're never mutating them. It's there's a user interaction or something, and then the entire thing gets re-rendered from scratch, which is a really easy way to think about things, but it doesn't lead to a good user experience because you've got that delay between when the user interaction happens and when the changed version comes down, and it loses context and stuff. And this gives you that simplicity, but it also deals with all of those problems that it would otherwise introduce, because it never has to actually fetch from the server. It never has to actually re-render everything. It only virtually re-renders everything and then does the small mutations that you would have to do yourself to make it happen. That's all enabled by these virtual DOM trees we're creating.
Now, are we going to get to the point where it actually does the diffing and injecting into the DOM?
No, we are definitely not going to get there. There is a lot of ground to cover. That is definitely one to leave for another day. I didn't realize how long we'd been running.
Yeah, time flies when you're reading the source.
Yeah.
Dum-dum.
Well, we want to dig into some more of this multi-job mixin stuff?
Yeah, let's do it.
All right. All right, so updating text components. Okay, so this is going to let us change the contents of a text component. So like where we had we here or something as a inner text component or food var baz. This is going to let us update those. So update. So when we call this, we increment our update depth and we set error thrown to true. Huh. Set our previous children to the rendered children. Iterate through unmounting the previous children, setting the new text content as the next content, and if nothing goes wrong, we set the error thrown to false. At the end, we decrement our update depth, and then if we've gotten out of our update depth, we check and see if we've thrown an error. If we have, we clear the queue, and if not, we finish processing the queue. So this is a way to short circuit if something goes wrong. All right, updating children. So this is going to update rendered children with a modified version. So again, we're incrementing our update depth, doing the error thrown thing to short circuit if it doesn't, or if there is an error. And then we're going to call our update children method with the next nested children in the transaction. As long as there's no error, we set error thrown to false. Decrement, and again, if we're at the end of our update, we either clear our queue if there was an error or continue processing the queue if there wasn't. This finally block stuff is kind of interesting. It's something I've used in instrumentation stuff before, but it hasn't really come up for me a whole lot of other places. But it lets you have a block of code that you execute after a try or a catch, whether or not there was an error that happened. But this lets the error actually propagate out of here, but it still executes this last block. Underscore update children, next nested children. So this lets us so it flattens the children starting with the next nested children. Sets the previous children to the last one that was rendered. If there isn't a next child and a previous child, we just no op name next index last index. Let's see, then iterating for each name and next children. We check to make sure it has its own property of next child. As long as it does, we don't skip this iteration of the loop. This is kind of a weird pattern, but it means that you don't have to put all of your logic inside of the conditional to check has on property. It means you can do that check in the negative and then skip the rest of the loop if you need to. Kind of an interesting style. Let's see. The previous child is previous children and previous children name. Previous descriptor, previous child descriptor. This is just pulling properties out of things, so it's easier to access later. You don't have to worry about trying to access properties on null or undefined things. Should update React component, previous descriptor, next descriptor. So this is the check here of has this changed, and if so, we go into here. This dot move child, previous child, next child, last index. Huh. Just not sure where move child is coming from or what that's letting us do here. Child to index, last index.
It's like it's just saying where it was, where it's going.
Yeah. Looks like we just queue up a move to move it on if we need to. Last index is math.max, the previous child matched index, and last index. Previous child received component, next descriptor transaction. Received component is a property off of the child itself. Okay, so this is more from the remounting stuff. Then resetting the mount index to the next index. So if we don't need to update it, we can just increment the index to what's higher, the previous child or the next index, and we can unmount the previous child. Okay, and so this is if we're adding a new child, we instantiate it with the descriptor mount child by name and index. Well, that's a descriptive name at least. So we can give it the next child instance, the name and the index, and mount it, and increment the index. And then at the end, we prune everything else that's no longer there. All right, unmounting rendered children. Okay, so this would be used to clear out stuff when it's unmounted, or I think when it's changed too.
Nick, could you quickly explain, just because my brain is starting to turn to mush at this point from following along, the concept of mounting and unmounting? What exactly does that mean in this context? What are they doing with the mounting?
Yeah, so So basically, as you mount a component, it goes through a couple of life cycles. It gets assigned a DOM element and then has a will mount life cycle where it creates all of the actual DOM nodes and then mounts those into the DOM and then has a component did mount event fire. So basically that gives you sort of there's this step of we've got a virtual DOM, then we prepare to mount it as an actual DOM tree, and then we have mounted it, and then it's got the same things in reverse. If we prepare to unmount it out of the DOM, so we remove the actual DOM nodes, and then we fire an event that we have actually finished that.
So you do, when it's in here, you're saying it does create like a document.create element?
Yes, essentially what we've got here is a virtual DOM, but we can mount that to an actual DOM. So it's really the mounting is that process of going from being virtual to being really in the DOM.
Right, but it does. Maybe I misinterpreted it because maybe my brain's turning to mush. But what it does is it stores the information, but it also stores like an actual DOM document, like a constructor like document.create element inside an array or a collection or something as well for it.
Actually, I'm not sure where that actually gets stored. Right, so when we've got when we mount these, where is it? Update. So
I'm sorry, it's just confusing so far to me with that, and it's not your stuff. I'm just trying to understand it.
Yeah, no. So so when we've got this child instance mount component, this mount image, I'm not sure if that has a reference to the actual DOM or not in it. I would bet probably not for garbage collection reasons.
Yeah.
So let's see if we can find where a child instance mount component comes from. So child instance is from instantiate React component.
Yeah, because I was thinking that you don't even do any constructors like that until probably in render, at least, like render component.
Yeah. No, most of the stuff is hanging off of it and gets called during the render component cycle. Okay, so instantiate React component is its own thing. Actually, I should probably here. Okay, instantiate React. That is not going to. Oh no, that worked. All right, so I got a couple of things: legacy descriptor, the descriptor. So here's where we instantiate the component. This gets that child passed in here. That's getting over the dev-only stuff. So if the descriptor is the type mock React class constructor, so let's assume we don't need to deal with mocks here. Here is this is all mock stuff. Normal case for non-mocks. Okay. So an instance is a new descriptor.type descriptor.props. Okay, so we're pulling the type property off of the descriptor that gets passed in, and then calling it as a constructor function, passing in the descriptor.props. a pretty weird pattern.
Yeah.
The if dev doesn't do anything. Instance.construct descriptor. Okay, so this is this actually sets up the internal instance. This will become decoupled from the public instance in future diff. Okay, so I believe that's the same construct function, or at least inherited from it from here. So this is back in source core React component construct. So basically the first big method we looked at there is what's getting called inside here. So basically all this is doing is calling properties off of the descriptor, calling the type property, passing in the properties, and then calling the construct of the instance, and then returning it. This is basically just a object builder, taking information we're passing in and calling it, and then calling the construct method off of it. So what we get back is not going to have a DOM component involved yet. This is all pre-DOM stuff being created. This is all sort of a pre-mount stuff, I guess. Hopefully that answers the question.
Yeah, it definitely does. Yeah, I would think that would be the case.
Yeah.
Oh, that's pretty cool.
Yeah, no, that makes sense.
Great to be able to verify your assumptions about how something works by diving in like this.
Yeah, it's lots of assumptions in here.
So, Nick, can you tell us a little bit about what you've been building with React, or is that internal stuff you can't talk about?
I don't think I can talk about it on the air.
Okay.
I can say I've been working on sort of the next generation of browser visualization stuff, and we're doing a lot of SVG stuff directly out of React. So it's kind of an unusual use case for React. It's sort of the kind of thing you'd often use in D3, but it's let us iterate really, really quickly, being able to build these things as React components and sort of treat the different layers as black boxes from the other layers. It's allowed us to change timescales and scrolling behavior and the kinds of things that you'd think of as days or weeks of work in a matter of hours.
Amazing.
Yeah, it's worked out surprisingly well.
Is there anything in your use of React that you find to be very confusing or a gray area, something that you don't quite understand yet?
Yeah, there's lots of stuff to not understand for sure. Just being such a big library, there's it makes it very hard to dive in and figure out exactly everything that happens at any point in time. The good news is it's solid enough that hasn't been a huge problem in practice, but it's definitely a little bit scary and kind of makes you want to investigate something like Mercury. Raynos has this library Mercury, which uses a lot of the same concept as React, but it's not nearly as big, but it's also not nearly as battle hardened. So there's some trade-offs there. But if you wanted to be able to read the whole source of the library you were using, that would be a good option with similar ideas behind it.
Nick, Oakley had a quick question there. Are you using React to actually replace D3?
So in some ways we are. We're using some of D3's helper functions still, things like polylinear scales and that kind of thing. But a lot of the life cycle of how you would enter and update and exit elements using D3, basically that life cycle of managing the actual SVG elements and stuff is all done in React for the stuff I'm working on.
Cool.
So it's definitely not a direct replacement, but basically replacing D3's rendering stuff with stuff done in React. Yeah.
Nice. Love to get some more questions if anybody has anything. So we had a few more viewers earlier, and I think we might have fried their brains.
Yeah, that's the danger of giving me a microphone.
So really interesting. I have to build some more. The only thing that I really looked at, I've looked at the source code for some of the stuff that we've been going through, but Flux, the React, is very interesting to me too. Have you worked with that at all?
No, so the stuff I'm doing is fitting within the context of a larger application. So I haven't had the privilege of just sort of starting from scratch on everything, and really the React stuff I'm doing is just fitting it in as the view layer. The Flux ideas are really interesting though. And I think some of the stuff we've been building have been using parts of those ideas on their own without sort of the whole. But we're doing the same idea of the events from the UI all bubble up to one place where they get handled together and stuff.
Yeah, have you worked heavily with the event system in React?
No, so most of the events that we're using, we're barely using the React event system, and then we've got our own simple event emitter outside of it that we're handling all these events with. So basically, we've got one instance of it that can have sub-instances, but it gets passed down to the events. So a click handler would basically just trigger an event on this one event emitter. There was something like, node bar click or something like that, and that state would then get handled at the level of the top component.
Right.
Yeah, so we've been, you can have state and properties at each level of component in this. Each one can track its own things, but basically what we've been doing is setting the state for everything at the sort of highest level component and letting that propagate down to its children through properties. So very few of our components have their own state. They just get the properties that they're called with.
I'm assuming that it's very composable as well.
Yeah.
How does it handle that with the mounting and the unmounting? Does it have a duplicated version of these, or does it point to like one area and say, okay, share this particular one? Do you know how that works?
I don't actually. That'd be a good question, but I think from what we're seeing here, I think each time you call a component, it's its own thing. So I think each div has its own object, and there's no pointing back and forth to them.
So we'll have lots of duplicates in a sense, or not duplicates, I guess, but similar components.
Yeah, for sure. I think the only way to avoid that would be using immutable data structures.
Yeah.
I know Facebook came out with with their own immutable JS. I haven't had a chance to look at it yet, though.
I think it's in React. I think it's like with invariant or somewhere in there. It's somewhere in like some util folder or something.
Okay.
There is a beautiful one and a key mirror and some other stuff, but yeah, I'm not sure how it's used. I was curious about that as well.
Nice. Yeah, using that or OMS stuff, there's no reason that an instance of a virtual DOM node couldn't be exactly the same as another one, as long as they had all the same properties and all the same children.
Yeah. Well, this has been really cool. A lot to absorb all at once. And we only go into like a couple of files. Because this library is really huge. It's like, Angular is pretty big, but this is pretty huge.
Yeah, React it's big, and it's pretty dense code too. This is it's not immediately obvious.
Yeah, I have to say though, all the bigger MVC or MV star or whatever frameworks out there, React and definitely included there having these comments about what each method does, so that helps a little most of the time. Sometimes you get weird comments like we had before, like, is this ever like true? And you're like,
yeah.
looking through like, okay, I guess I should be warned about this.
Yeah, it makes me feel some sort of human connection when you see a to-do comment in the code as you're reading through it. You're like, oh, I could have done that. Yeah.
Absolutely. Well, Nick, you must be starting to fry here. Do you have anything else you want to cover or talk about before we call it a day?
No, I think this seems like a good stopping point here.
Well, thanks a lot, man. This has been really awesome, Nick.
Well, thanks for having me on.
Appreciate it.
It's been a lot of fun.
Love to have you back if you feel like doing it again. If not, I completely understand. A lot of work. So
let me recover first.
20 episodes.
So, yeah, for anybody watching this, we do this once a month, first Thursday of every month at the same time, 7 p.m. Eastern, 4 p.m. Pacific. And if you'd like to look at some particular piece of code and talk through it with us, like Nick just did, let us know. And we're on Twitter at Read the Source. What else, Eric? Anything else that we have?
No, I mean we've covered some Angular, a lot of Angular, a lot of Polymer. Now React, so more React definitely. Any library or framework that the point is to go through the source code and understand it earlier, Christian. So definitely open to new ideas and new people coming on.
We thought about at one point going through some of the Node.js source code, both the core library, core modules, and also maybe some of the C++ stuff, and see how the event loop is wired up. I think what's the event loop implementation there? It's called libuv or something like that. Is that right?
Yeah, libuv is the underlying C stuff down there. It's I've heard a lot of ranting from some friends who work on that there's not really an event loop that you can point at. There's no. An event loop's a great concept, but there's no piece of code that really represents that whole life cycle. So I'd love to watch someone dig into that.
Well, if you know somebody, send them our way.
Yeah, I'll see what I can do.
All right, man. Well, thanks again.
I'd like to see some Dart. Going through some Dart stuff, that'd be cool too.
Yeah.
Yeah. All right. Well, thanks, guys.
Cool. Thanks, everyone.
Good job.
Thank you.